Sorry about that. And activin is very important. It regulates bone mass. So what happens is if you block activin, you get increased bone mass. So you block myostatin, increase muscle mass, activin, increase bone mass. So next slide. The next slide. So what you see here are CAT scan images. This is actually called micro CT because you can see it really in a fine-tuned way. And on the top panel are bones from our mice that are just plain normal mice. But on the bottom panel are our mice treated with the experimental drug. And as you can see, the bone density has really increased dramatically. And so what we're going to do when the mice return to Earth from space is actually do this micro CT. But we're also going to use another imaging modality called bone density or DEXA scans. And you've probably all heard of these DEXA scans. They're used in humans all the time and are very accurate for assessing bone density. So what we're going to do is do these DEXA scans on the mice on Earth, and the astronauts up at the International Space Station will be doing these DEXA scans on the mice up in space. So Sagen has already told you that astronauts lose a lot of muscle mass. And as you heard today, they also lose a lot of bone mass. So really, what you want to do is to be able to improve both muscle mass and bone mass together in order to give the most benefit. If we could do that, it would really dramatically help the astronauts, but it would also help a lot of people here on Earth who suffer from really debilitating conditions leading to muscle wasting and bone wasting, or both. So in children and adults, there are lots of conditions that cause bone wasting, that cause muscle wasting, that cause both. But basically, all of them cause immobility. And when you get immobility, you end up getting bone fragility. And when you get bone fragility, you get osteoporosis, which all of you have heard of. And osteoporosis is bad because you end up getting a lot of fractures. And when you get fractures, that creates this cycle of immobility. The immobility leads to decreased activity. That leads to decrease in muscle mass. And you can see you get this vicious cycle between loss of bone and loss of muscle. So really, by testing this experimental drug, we are hoping to be able to test a novel therapeutic method of combating, really, both muscle loss and bone loss, not only in astronauts in space, but really for a lot of people here on Earth. Thank you, and excuse my hoarseness.
All right, let's take a few questions. Here you go. Yeah. All right up front.
Charles Axon with at military_flight. How often will the crews on board station have to take the medicine? And is it in pill or is it by syringe?
So that's a great question. So this will not be done on the crew, although that would be the ultimate goal. But for the mice, it would be given once a week.
Your vision, how do you have a vision for the crews once this FDA has approved it and it's gone forward?
So, I mean, that's a great question. So right now in mice, it's being given by injection. And this is most likely something that would have to be given by injection to get into the bloodstream. The goal ultimately, and this, who knows how far that would be about once a week. And you should comment.
Yeah, I think it's probably too early to say for sure. And as drugs get developed, there's lots of fine tuning to increase things like half-life and and you have to determine sort of what the therapeutic dose is going to be and so forth. So hopefully it would be something less frequent than that, but of course it's too early to say until it actually get there.
Does anybody else have a question? Right back here.
Hi, Christina Rowland. I have a question on how the drug itself actually works as well. You mentioned stuff like with people in older populations and people who are bedridden and may not be able to exercise and stuff like that. I understand that myostatin allows you to create more muscle mass, but for those that are unable to move at all, will it still help them because they're still not moving, so is the body still incentivized to create more, that kind of thing, or is it mostly for stuff like that bull that is actually moving and still able and capable?
Yeah, that's a great question, and that's part of the reason we want to do the study. It's because we want to know what will happen in a setting like microgravity, where you have lots of muscle loss throughout the body and bone loss, and the question is, in that kind of setting, can you actually recover that by giving drugs that will block this particular pathway? But we know that in studies in mice, mostly in mice, but there's some human trials going on as well. We know that in lots of different kinds of disease settings where you lose, for example, muscle function, you can compensate for that by blocking myostatin activity. So we know that it works in some settings, but microgravity really gives us a unique opportunity to look at it in this type of setting, which is most closely related to what you would see, for example, in the elderly.
Okay, we have time for one more question.